Section 1.4 has two topics in it. The first one is partitioning. We'll start looking at partitioning with this graph. Point P is 1/4 of the way from A to B. So that's a direction. They're telling us we're going from point A to point B. And point P is located 1/4 of the way. So what we could do is we could look at the distance between A and B. Now I know the segment connecting them is on a slant, but you could look at their distance and break it down horizontally or vertically. So if I went horizontally, I'd go like this. I'd go 1, 2, 3, 4, 5, 6, 7, 8. So horizontally speaking, those points are 8 units apart. So I could take 1/4 of 8, which is 2, and add that to the x-coordinate of A. Now A is at -1, 2. So I'm going to take -1 and I'm going to add 2 to it, which gives me +1. So point P has a +1 x-coordinate. So point P is located here at the point 1, 4. To find point R, halfway from A to B, I'm going to take half of 8, which is 4, and I'll add that to A's x-coordinate. So -1 plus 4 is 3. So the coordinates of R are 3, 6. So R would be right there on the segment. And now we'll continue with number 3 and 4. We don't have the other endpoint of the segment. So the segment is AB, but notice how we have A and we have the letter P. We don't have B. P is 3/4 of the way from A to B. So clearly B is somewhere beyond P. It's out here somewhere. We're not sure this moment where that is. So what we could do is we could think of the horizontal distance from A out to B as being N. So when we do 3/4 of N, then we would be how many units along the x-axis to P. So I'm going to count from A to P. I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So P is 12 units horizontally from A, which is 3/4 of the way to B. So we could set up this equation here, where N is the distance from A to B. And now we just need to solve this equation. I'm going to multiply both sides by 4/3. That'll get rid of the 3/4 in front of the N. So the 3 cancels with the 12 and leaves a 4. So N is 16. So now all I need to do is take the ordered pair for A, which is -4, -2, and I can add 16 to -4, which will get me +12. Then I could do the same thing to figure out how to change the y-coordinate, because B is obviously off the graph. I can't just count the spaces. So let's do the same approach, but for vertical distance. So A is down at -2, and how far up is P from there? 4, 5, 6, 7, 8, 9, 10, 11, 12. it's the same 12 units. So we don't have to do a calculation again. We already know it would be 16. The n would be 16 going vertically. So I'm going to add 16 to -2, which will give me 14. So the coordinates of B in this situation are 12, 14. Now we have the same idea, but P is now 1/3 of the way from A to a point C. So if I think of N as the horizontal distance from A to C, then I know 1/3 of N would be the distance 12, because P we know is 12 units from A. And now we're going to solve for N. So I'm going to multiply both sides of the equation by 3. That gives me N is 36. So I'm going to take the ordered pair for A, which is -4, -2, and I'm going to add 36 to both the x coordinate and the y coordinate. And I'm doing it to both because remember, P is 12 units from A, whether you go horizontal or you go vertical. -4 plus 36 is 32, and -2 plus 36 is 34. So point C is at 32, 34. Okay, we're going to do the same thing for number 7 and 8. Okay, the last page for partitioning is when they give us ratios. So I'm going to look at the points are A and B, and we have segment AB here. And now point P is in between A and B again. This time P is dividing the segment up into a ratio of 3 to 5. So I would like you to think of that as 3 parts to 5 parts. 3 parts to 5 parts for a total of 8 parts. So P is 3/8 of the way from A to B. So you take the first number, because this is a directed line segment, so we use the first number for our fraction, and we had a total of 8 parts, and that gives us a fraction of 3/8. Now we can use that fraction like we did in the last page, but I need to count how far apart A and B are. And I don't know if you noticed, but A to B horizontally is different than A to B vertically. So what we do when we look at it horizontally, we call that the change in X. And that's denoted with a triangle, the change in X. So we're going to count how many places it is from A to B, and that's 16. And now we'll count the change in Y. The change in Y. Notice I put the triangle again. That means the change in Y. And the change in Y is 8. Okay? So when I do this, I'm going to take 3/8 of the change in X, which was 16, and that gets me 6, and then I'll take 3/8 of the change in y, which is 8, and that gets me 3. So when you start with point A, which is at -8, 5, and you move 3/8 of the way down the segment, horizontally that changes the x-coordinate. So I'm going to either add or subtract 6. When I go from A to B, I'm going to the right. So you're adding on to x when you go to the right. So we're going to add 6 to the x-coordinate. But notice what happens from A to B vertically. From A to B, we are going down. So you're going to have to subtract from the y-coordinate since we're going down. How much are you going to subtract? That's right here. That was the 3/8 of 8 that we did. So you're going to subtract 3 from the y-coordinate. And the new point, point P, will be located at -2, +2. So P would be at -2, +2. Okay, we'll do that again. Now in number 10, partitions in a ratio of 1 to 1. So that's 1 part to 1 part for a total of 2 parts. So when you go to make your fraction, the 2 goes on the bottom and the first number goes on the top. It's always going to be the first number because it's a directed line segment. We're always going from A to B in these math problems. So I'm going to take half of the change in x, which we already found is 16, because the picture's the same. We're using the same picture. That's obviously 8. And then 1/2 of the change in y, so half of 8 is 4. And just do the same thing again. Now take point A, which is at -8, 5, and make these changes. You're going to add to the x-coordinate because we're going from the left to the right. When we're going from point A to point B, we're going from the left to the right. But then when we're going to point B, we're also going downhill. So the y-coordinate is going to be changing by going down. So we're going to subtract the 4 from 5. See the 4 we got here? We're going to subtract it from 5 because we're going down from A to B. Okay, -8 plus 8 is 0, and 5 minus 4 is 1. So point Q's coordinates are 0, 1. Okay, we're going to do the same thing with number 11 and number 12. There's a total of 4 parts. So the 4 goes on the bottom of the fraction, and the first number goes on the top of the fraction.